A very good day to Prof. Tarmizi and Dr. Nazahia. We are from Group 4 and we would like to present our video presentation.
My name is Tan HUAI. My matrix number is AF1902222. Today, let me give the presentation regarding the introduction of this project. This report is about the analysis of rainfall and water level data of selected stations that have been taken from the Department of Irrigation and Drainage website. The objective that we find is to justify the method of measurement for the rainfall, streamfall, and hydrograph. The second objective is to determine the measurement for the rainfall, streamfall, and hydrograph, which in particular location of case study. Next, we go to the location of study. Our group has chosen the rainfall station and water level station in Glen. There are three rainfall stations in our case study, which are Taman Sri Muda, Taman Sentosa, Tunggu Keris. Meanwhile, one water level station that we selected is in Grand River. For the reason that we chosen the station is there was once a heavy rain happened in Glen, which has led to the occurrence of flood and caused the water level rise gradually in Grand River. The second reason is the location that selected has some problem with existing drainage system flood with waste and run off water from new development.
Hello, I'm Muhammad Adi AMZAR from YAZID and I'm present about meteorology. Rainfall. Rainfall data generally are collected using electronic data logger that measure the rainfall in 0.01 inch increment every 15 minutes using either a tipping bucket rain gauge or a collection well gauge. 24-hour rainfall totals are tabulated and presented. A 24-hour period extends from just past midnight of the previous day to midnight of the current day. Snowfall affected data can result during cold weather when snow fills the rain gauge funnel and then melt as temperature rises. Snowfall affected data are subject to error. This is the graph of the relation between daily rainfall and even rainfall. Water level data. Water level is one of the most commonly measured parameters as accurate level data are essential for many applications. While climate change, pollution monitoring, and industrial water usage are broad reasons for monitoring water level, more specific applications are discussed throughout this study. Collection data by using Google Earth. Google Earth is a computer program that renders a 3D representation of Earth based primarily on satellite imagery. The program maps the Earth by superimposing satellite image, aerial photography, and GIS data onto a 3D globe, allowing users to see cities and landscape from various angles. In this study, we focus on the area of common plot of Taman Sri Muda, Taman Sentosa to Keris, such as its geographical characteristic in terms of the terrain profile, gradient slope between section and cross section of the river. These are the location of study by using Google Earth. A system of precipitation data can be transformed to aerial estimations using any of the following methods. First, arithmetic mean method. Second, Thiessen polygon method. And Third, isohydral method. Discharge is typically recorded at gauging stations located at various places along the river. The discharge river is determined by using method as follows. First method is rational method. The rational method depicts a link between rainfall intensity and catchment area as the independent factor and peak flood discharge as the dependent variable. The calculation method is referring to MSMA second edition. Second method is cross-section profile method. River cross profile depicts a cross-section of a river channel and valley at various places along its path. Even so, this merely the average velocity across a cross-section of a river reveals that velocity varies from side to side. Thank you.
My name is Lin Zihong, and now let's proceed with the part of analysis and result. We use the average values for the collected rainfall data starting from 1st of May till 7th of May for each rainfall station to calculate the proposed catchment area. To proceed with the calculation, firstly we need to know the catchment area. The catchment area for this project is 106950 hectare. The first method of calculating mean error is arithmetic mean method. We add up the average rainfall data for the 3 selected rainfall stations and divided by 3. And then the value we get for average precipitation is 6.2 mm. Next is Tyson polygon method. In this method, we connect these 3 rainfall stations with straight lines and then construct perpendicular bisector of the connecting lines, and as well as form polygons with these bisectors. Then we determine the area of the polygon and calculate average precipitations using the formula where polygon area for each station times precipitation and divided by total polygon area. Here the answer we get is 6.1 mm. The last method is isohydral method. We divide the catchment area into 4 intervals by drawing lines of equal precipitation according to the rainfall stations. The formula is sub error between 2 isohydral lines multiplied by average precipitation between 2 isohydral lines and then divided by total error. And then we get the average precipitation about 4.7 mm.
Hi, my name is Melvern HENG with matrix number AF190103, and I would like to present stream 4 or water level data. For analysis, we have divided the data into 3 weeks from cross-section 1 for easier analyzation. First, we will calculate the water flow, and here is our data for 31 days, starting from 1st of May until 31st of May. Next, we will separate the base flow using the straight line method, and each week have different value of base flow. And the third step is calculation of direct flow and plotting unit hydrograph. The calculation of direct flow can be calculated using total flow minus base flow. And the total direct runoff volume is the total direct flow times the time, which we will convert it to cubic meter. And the equivalent runoff depth is by dividing the total direct runoff volume with catchment area. This is the unit hydrograph for week 1, unit hydrograph for week 2, and unit hydrograph for week 3. That is all for base flow calculation. Thank you.
Get the peak flow of the proposed catchment boundary. We can use the rational method. The formula of rational method is Q equals to C times I times A and divided by 360, where Q equals to peak flow, C equals to runoff coefficient, I equals to average rainfall intensity, and lastly, A equals to drainage area. According to Manuel Salera Musra Alam second edition, runoff coefficient is for minor system which is smaller than smaller than or equals to 10-year ARI of land use link and terrace house is 0.8. Then we calculate overland flow times TO and we get 117.98 minute. Because of the limitation of this project, therefore we assume touch or concentration TC is equals to TO. For the curve IDF, using the value for TC that we just calculate, the rainfall we can get the rainfall intensity ice, which is equals to 52 mm per hour. Then we substitute all the values we obtained into the formula that I mentioned previously, and then we will get 12358.67 meter cube per second. We calculate the discharge for the cross section using slope error method. We recorded all the information regarding three cross section of the river in tables, and then we use the slope error formula, which is Q equals to 1 over N times A times out to the power of 2 over 3 times S to the power of 1 over 2. After the calculation, we can see that the total discharge value for cross section 1 is equals to 101.534 meter cube per second. As to the discharge value for cross section 2, we get 24.548 meter cube per second. And lastly, the discharge value for cross section 3 is 89.419 meter cube per second.
Next is discussion. From this report, it is proven that the network of precipitation measurement can be converted to area estimates using any number of techniques, which include arithmetic mean method, Tyson polygon method, and isohydral method. Those methods produce a different result with different calculation method, which is we get 6.2 mm for arithmetic mean method, 6.1 mm for Tyson polygon method, and 4.7 mm for isohydral method. Here we can see that arithmetic mean method and Tyson polygon method give us almost the same value as for isohydral method, give us a value which differs from those two methods mentioned before. For stream flow or water level data is harder to analyze as the data is for 1 month, and usually base flow separation is used for a single rainfall event. To make it easier to analyze our unit hydrograph, we have separated the 1 month data into weekly analyzation. That is all for the discussion. I'll pass it to YAZID for conclusion.
Hi, my name is YAZID. I will present for the part conclusion. Hydrology is essential in solving problems in development, utilization and management of water resources. Rainfall acts as one of the major water resources on Earth to maintain our environment by replenishing water to the Earth. This is because the water level and water quality is affected by the duration and amount of rainfall. Therefore, rainfall measurement is essential to validate weather, radar, and satellite rainfall estimation in agriculture. It is recommended that the rainfall can be measured at a higher location by using tipping bucket rain gauge to get a more accurate measurement. To measure rainfall, it takes a week to collect the rainfall data, which is from 1st May until the 7th May. To determine the mean area rainfall, there are three different methods, which is arithmetic mean method, Tyson polygon method, and isohydral method. Hydrograph analysis is often combined with rainfall analysis to investigate how a watershed responds to rainfall. Thank you.